Imagine standing in one of the driest places on Earth. No rivers, no forests, almost no rain, just millions of square kilometers of desert. Now imagine looking down from space and seeing this. Geometric green fields, straight roads, irrigation networks, agricultural machines, entire patches of farmland appearing inside the desert. This is Egypt, a country where the overwhelming majority of the land is desert, and where most people live around one narrow river valley, the Nile. For thousands of years, Egypt survived by farming beside that river. But today, Egypt faces a problem that cannot be solved by simply planting more crops along the Nile. Its population has exploded. Cities are expanding. Traditional farmland is under pressure, and food security has become a national priority. So Egypt is attempting something extraordinary. It is pushing agriculture outward, into the desert, not with rain, not with natural rivers, but with pumps, pipelines, canals, water treatment plants, precision irrigation, roads, electricity, and billions of dollars of infrastructure. But there is a catch. Every green field needs water, and Egypt is already one of the world's most water-stressed countries. So the real story isn't simply, how did Egypt make the desert green? It's this. Can Egypt keep it green? Look at Egypt from space. The contrast is extraordinary. The Sahara dominates the country, but running through it is a narrow green corridor, the Nile Valley, and at its northern end, the Nile Delta. This is where much of Egypt's traditional agriculture developed. For thousands of years, the river provided the water that made farming possible. But geography created a problem. Egypt's population kept growing, while naturally productive land remained limited. The result was intense pressure on the Nile corridor. Cities expanded, roads appeared, buildings replaced agricultural land, and the same basic problem kept returning. Where do you put the next generation? Egypt's answer was increasingly radical. Don't just build upward. Don't just build outward around the Nile. Build somewhere else. Build in the desert. At first glance, the idea seems almost absurd. Agriculture needs water. The desert simply doesn't have enough. So why even try? The answer is necessity. Egypt doesn't have many alternatives. Desert reclamation offers the country a way to pursue several goals at once: more agricultural land, increased food production, new communities, new roads, new economic zones, and less pressure on the historic Nile Valley. But there's a fundamental difference between farming naturally fertile land and creating farmland from scratch. With natural farmland, nature provides part of the infrastructure. In the desert, humans have to build almost everything. The water supply, the irrigation network, the electricity, the roads, the drainage, the agricultural systems, even the communities that will grow around these new farms, all must be engineered and constructed from the ground up. So Egypt's desert agriculture is not simply a farming project, it's an engineering project on a national scale. One of the most famous examples of ambitious desert transformation is Toshka. Far from the crowded Nile Valley, Egypt envisioned turning vast stretches of barren desert into productive agricultural land. But there was an obvious challenge. There's no convenient river flowing through the heart of the desert. So, engineers had to move the water. That meant building canals, installing powerful pumping stations, and planning massive infrastructure projects. Water from the Lake Nasser region could be directed toward these new development areas. The ambition was enormous. Take water, move it across an environment that naturally receives very little rainfall, and create a new agricultural frontier. For Egypt, Toshka became a symbol of something much bigger. The belief that engineering could overcome geography. But it also taught an important lesson. Building infrastructure is one thing. Creating a commercially successful agricultural ecosystem is another. Years later, Egypt's desert reclamation strategy entered a new phase. Instead of relying on a single giant project, the country began pursuing multiple agricultural development zones. One of the most important is the New Delta. Here, enormous areas of desert are being developed for agriculture. The transformation is difficult to appreciate from ground level, so look from above, brown, 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 then green. Straight agricultural plots appear across the desert. Roads connect them. Irrigation networks feed them. And processing and transportation infrastructure begins connecting farms to markets. The objective isn't just to grow crops. It's to create an agricultural economy in a place where there wasn't one before. But behind every green field is a machine. Water has to arrive. And in some of Egypt's newest agricultural zones, that means massive water infrastructure. Pumping stations move water. Treatment plants process water. Pipelines and canals distribute it. Drainage systems manage excess water. And modern irrigation systems deliver water to crops. One of the most important ideas is water reuse. Instead of treating water as something that can be used once and discarded, Egypt increasingly views water as a resource that must circulate through the system. Drainage water can be treated. Wastewater can be treated. Water can be reused for agriculture where appropriate. The objective is simple. Get more agricultural production from every available drop. Traditional agriculture can be surprisingly inefficient with water, but desert agriculture doesn't have the luxury of wasting it, so technology becomes essential. Drip irrigation, precision application, modern irrigation scheduling, soil monitoring, mechanized cultivation, greenhouses, data-driven farming. The principle is simple. Don't give the entire field more water than it needs. Give the crop what it needs, where it needs it, when it needs it. That sounds simple, but across hundreds of thousands of acres, small improvements can become enormous. And this is where Egypt's desert experiment becomes more than a land reclamation story. It becomes a test of modern agricultural efficiency. And now we reach the biggest challenge. Water. Egypt depends heavily on the Nile, but the Nile is not an unlimited resource. The country is already under significant water pressure. And climate change, population growth, rising demand, and regional water politics add even more uncertainty. So every new agricultural project creates a difficult equation. More farmland means potentially more food, but more farmland can also mean more water demand. This is why Egypt's future may depend less on simply finding more water, and more on using the water it already has much more efficiently. This is where another technology becomes critical: water treatment. Egypt has invested heavily in large-scale water treatment and reuse infrastructure. The concept is powerful. Instead of allowing water to leave the economic system after one use, treat it, recover it, reuse it, then send it back into productive agriculture. This creates something closer to a circular water economy. The goal is not to manufacture water. That is impossible. The goal is to make each unit of available water do more work. And in a country surrounded by desert, that could be one of the most important technologies of all. But look beyond the fields. Something else is happening. New roads, new towns, new industrial areas, new logistics networks. Agricultural development is becoming connected to urban development. Because a farm needs workers. Workers need homes. Homes need electricity. Businesses need roads. Food needs warehouses. And crops need markets. So Egypt's desert strategy is gradually becoming something much larger. It's an attempt to move economic activity away from the traditional Nile corridor. The desert is no longer simply empty space between cities. It is becoming a development frontier. And then there is the Nile. This is where Egypt's agricultural transformation becomes geopolitical. The Nile does not belong to Egypt alone. Its basin extends across multiple countries. Water decisions upstream can affect countries downstream. And Egypt's agricultural future depends heavily on the reliability of its water supply. That makes agricultural expansion part of a much bigger national strategy. Egypt needs more food, more productive land, more efficient water use, and reliable access to water. So when you look at a green field appearing in the Sahara, you aren't just looking at agriculture, you're looking at national strategy. So what is Egypt actually trying to accomplish? It isn't simply trying to turn the entire Sahara green. That would be impossible. The real objective is more strategic. Take carefully selected areas, build the infrastructure, deliver water efficiently, create productive agriculture, connect farms to markets, build communities around them, and gradually expand Egypt's usable economic geography. It's a controlled battle against the desert, and Egypt has already demonstrated that it can work in specific locations. But scale changes everything. A project that works on one farm must work across hundreds of thousands of acres. A water system that works today must keep working for decades, and crops must remain economically viable. That is the real test. The desert has no mercy. If water becomes more expensive, the economics change. If groundwater declines, the model changes. If soil salinity increases, productivity can fall. If energy costs rise, pumping becomes more expensive. If crops cannot generate enough revenue, farms can become economically difficult to sustain. And if water resources become increasingly constrained, the competition between cities, industry, and agriculture becomes harder. This is why the biggest question isn't whether Egypt can engineer green fields. It clearly can. The question is whether it can engineer a sustainable system. The future could look very different. Imagine vast desert agricultural zones connected by highways, automated machinery harvesting crops, sensors monitoring soil moisture, AI optimizing irrigation, water treatment plants recycling enormous volumes of water, solar and other energy systems powering agricultural infrastructure, and agricultural communities emerging around newly productive land. If this works, Egypt could create a fundamentally different relationship with its desert, not eliminating the desert, but strategically using parts of it, turning selected areas into productive economic zones. That distinction matters, because the future of Egypt may not be about defeating the Sahara. It may be about learning how to operate inside it. From the ground, it looks like a miracle. From the air, it looks like engineering. From space, it looks like Egypt is slowly drawing new green shapes across the Sahara. But behind every one of those shapes is the same question: water. Egypt has shown that it can move water into the desert. It has shown that it can build irrigation systems. It has shown that it can reclaim land. It has shown that technology can create productive agriculture in extremely difficult environments. But the ultimate challenge is different. Can Egypt do it at massive scale? Can it produce more food without consuming unsustainable amounts of water? Can it make the economics work? Can these new agricultural regions remain productive for generations? And can Egypt expand its farmland without making its water problem even bigger? Because Egypt isn't simply trying to make the desert green. It is attempting something much more ambitious. It is trying to change the geography of where Egyptians can live, where they can work, and where the country's food can be produced. For thousands of years, Egypt's civilization followed the Nile. Now Egypt is attempting to push beyond it, into the Sahara. And perhaps the greatest question isn't whether Egypt can make the desert bloom. It already has. The question is, how much desert can Egypt afford to make green? Africa's past, Africa's power, Africa's future. Subscribe for more documentaries exploring Africa's mega projects, resources, agriculture, infrastructure, cities, and geopolitical transformation.